Now we are moving back to combining like terms. So whenever we see the operation addition, we are combining like terms. So first of all, we have 3x plus 2x. So again, x represents a number or some kind of object. So for example, x can represent a dollar. So you have $3 plus $2, and to do that, we get $5. And notice that in the process of adding them, we don't really change the dollar sign x, and we just adding the numbers in front of them. Again, the numbers in front of them tell us the quantity, how many of x's do we have, and how many of x's do we have, so we combine them. So let's say if somebody gave you 3x's and then they gave you another 2x's, together you have 3 plus 2, 5x's. And just like, 3 apples plus 2 apples, that gives us 5 apples. So to do addition of algebraic expressions, first of all, we have to make sure they match. Again, we call them like terms in algebra. And in real life, just think of x as the same item, the same object. And so let's take a look at these two here, 3x squared plus 2x squared. And notice even though they have squares, they still match. So that means as long as they match, they represent the same thing, same object, the same number. So that means they are like terms again. So we just need to know the quantities of both of them. So of course we have 3 of them here and then 2 of them there together, and we combine them to get 5x squared. And again, x squared doesn't change. We only add the numbers in front of them. So again, the numbers in front of them tell us the quantity. So for subtraction, it would be similar as long as they match, and we can just subtract the numbers in front of them. So 3 minus 2, if you have 3 apples and you gave away 2 apples and then you left with 1 apple, so you end up with 1x squared. Again, 1x squared means 1 times x squared. Anything times 1 is itself. So if it's 1, usually we omit that 1 there. All right, if we have 3xy plus 2xy, again, they match. That means they are like terms. So we can just add the quantity of them. So 3 plus 2, that gives us 5xy. And now let's look at 3x plus 2y. So notice that I use a different color. X and y, they may not represent the same number. And again, x can mean apples, y can mean oranges. So 3 apples plus 2 oranges, not going to give us 5 apple or 5 oranges because they don't match. They're not the same item, not the same thing. And which means they are not like terms. In mathematics, we say they're not like terms. If they're not like terms and they don't look like, we cannot add them. Because if you have 3 of this plus 2 of that, you cannot really add them because they're not like terms. All right, so let's look at this example here. We have many terms. We call them terms here. So the first term, whenever you see a plus or minus, that's the second term. Another plus, the third term, and another minus is the fourth term. Between this number and the variable, there's nothing. That means multiplication. So again, the multiplications, they are considered, they have higher priority. So they're sort of like stuck together, and stuck together, and stuck together. And then they're joined by the pluses and the minuses. So following the order of operations, we're supposed to do multiplications, but the multiplication is between a number and a variable, 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 which cannot be done because we have to know what the variable is, what x is. If we don't know what x is, we cannot multiply a number and a variable. So we're going to move on to do the addition. Again, multiplication, division, addition, subtraction. So multiplication has a high priority than addition and subtraction. But since we cannot do anything about these multiplications, we can move on to do addition and subtraction. Now, if we add or subtract, expressions with variables, we have to remember they must be like terms. That tells us they are the same thing. So first of all, I located x squared and x squared. They both x squared, so they are like terms, or they can represent the same thing. And x, they're both x's, so they represent the same thing. So we have to make sure they match exactly, not only the variable x, but also the exponents. So we can combine these two because they're both x's. And think of x squared. They're both x squares, so think of them as like apples. We can combine 6x and minus 9y because they're both x's. And when we combine like terms, we keep the variable. Again, think of this as apple. So we -5 plus 2. I guess apples, usually we don't say -5 apples, but think of this as dollars. So we have -$5 plus $2. Together we have -$3 because -5 means $5 in debt and $2 credit. So we have more debt than credit, and we have $3 more debt after combining them. And for the other two, again, the variables, so if you have $6 minus $9, and then you have 6 minus $9, and 6 minus 9, we know it's -3, because if you have $6 and you overspend, and then you owe $3. So when we get here, we have to stop because one of them has the variable x squared, the other has x, they don't match. So it's kind of like this is a maybe this is like US dollars, and maybe this is like Canadian dollars, and they don't really match, and then we cannot really combine them unless we convert them to the same currency. But because we don't know what they are, we cannot really convert them. So that's all based on the information we have. That's all we can do. So we cannot combine the terms that are not like terms. So this is the final answer.